The first step when you complete the square is moving the constant to the other side. So x squared minus 13x equals negative 42. Now we have to create the factor, and remember that the factor is half of the middle term. So x minus, what's half of 13? 13 over 2. And we prefer the fraction. The decimal kind of works, but it makes the answer more messy in the end. So minus 13 over 2. Well, if my factor is negative 13 halves, what is my perfect square? 13 times 13 is 169 over 2 times 2 is 4. So plus 169 over 4 plus 169 over 4. Okay, so negative 42 plus 169 over 4 is 1/4. If you plug, yeah, I don't think it's negative. Let me double check, I don't remember. So negative 42 plus 169. It's a running man. Okay, so now I take the square root, and I get x minus 13 halves equals plus or minus, what's the square root of 1/4? 1 over 2. Add 13 halves, add 13 halves, and I get x equals 1 plus 13 is 14 over 2, which is 7. For the other root, we have negative 1 plus 13 is 12 over 2 is 6. Would this have factored if we would have tried that? Yeah, it would have. Okay, but you need to know how to complete the square, because if the roots are imaginary or irrational, then you have to factor it. Also, there's something else we're going to do in a while where completing the square is necessary. But if I had a quadratic like 8x squared plus 3x plus 1, then I have to divide by 8 and the fractions get quite nasty. There is another way to find the roots. And really it's just completing the square, but it's doing it in a different form. So, what if I take a generic equation? So this is considered a general equation. It represents all possible quadratics. Well, if I complete the square on this quadratic, with a, b, and c being unknown, the equation I get in the end will be a formula that will complete the square for me. And it's really nice for quadratics like this. Completing the square is not bad if the leading coefficient is a 1. It's especially not bad if the middle term is even. So, let's complete the square on this. What should I do first? Well, before I move the c over, I need to divide by a. If a equals 1, then I don't need to worry about it. But if a is a random number, what's the chance that it's 1? 1 out of an infinite number, which is 0. 1 over infinity is actually 0. So there's a 0% chance that it's going to be a 1. Okay? So I divide by a. That cancels. So I have x squared plus b over ax plus c over a. Now I move the c over a to the other side. So x squared plus b over ax, leave a space, equals c over a. Okay, now don't write this, but on your worksheet yesterday, or which was Friday, you might not have noticed, but what if I had x minus 1 squared equals, oh, I don't know, 16 over 9. Now I take the square root, and I take the square root, and I get x minus 1 equals plus or minus, well, let's make this not a 16. Let's make it a 24. So 24 simplifies to be 2 root 6. 2 root 6 over 3. Now I add the 1, and I get 1 plus or minus 2 root 6 over 3. But that's not totally simplified, because I need to add these together. Well, in order to add two fractions, they need to have a common denominator. What would the common denominator be? 3. So I'm going to change this to a 3, and I also need to change the top to a 3, which would be 3 plus or minus 2 root 6 over 3. Okay, and that actually happened a couple times on the last worksheet. So you just need to fix this side to match. So over here, what would my factor equal? Half of b over a. Well, how do you divide a fraction by 2? You double the denominator. So x plus b over 2a. If b over 2a is my factor, what's my perfect square? Negative b, plus b squared over 4a squared. A times b over 2a times 2a. So I add b squared over 4a squared to the other side. Well, now these two fractions need common denominators. What's the common denominator going to be? 4a squared. So if it's going to be 4a squared, what is this side missing? It's missing a 4 and a second a. So I'm going to times this by 4a. And just for simplicity's sake, I'm going to flip them around. So I get x plus b over 2a squared equals b squared minus, sorry, that's a negative c, minus 4ac over 4a squared. Hang on, we're almost done. Now I take the square root. And I get x plus b over 2a equals plus or minus the square root of b squared minus 4ac over, what's the square root of 4a squared? 2a. And notice I have a common denominator now. So I'm going to subtract b over 2a, and my quadratic formula down here, I don't have room, but you'll put it down here, is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. Now, this will solve for the roots on any quadratic as long as you don't divide by 0. Well, what number makes the bottom 0? A equals 0. But I can guarantee you that a is never 0. How come? If I look at the original quadratic, if a is 0, what do you notice? It's not a quadratic, it's linear. So if a equals 0, then it's no longer a quadratic, so that's never going to happen. If you have a linear equation, you're never going to plug the numbers into the quadratic formula. It only works for quadratics, so we don't have to worry about that. Now, the nice thing about this is it does all of the complete the square steps for us. All those little tricks we did, move the c over, divide by 2, square, take the square root, subtract over, all of that is hidden inside this formula. So to get the roots, you just plug in a, b, and c, and then simplify. And it works especially well when you have a leading coefficient. So, I never want you to forget the quadratic formula. You ready? I can see some of you guys dressed like that. So that's the quadratic formula to Pop Goes the Weasel. Let me play it again. So you won't be able to sleep tonight without remembering the formula. I think there's another one with, here's one, here's one with words. Okay, now, I don't know why it's so zoomed in. Okay, here we go. One more time. Why isn't it working? I don't know. I'm just glad I didn't have to do it. Okay, so let's use the quadratic formula. We have 6 problems we're going to work together. So I'll write the formula over here. Negative b plus or minus the square root b squared minus 4ac over 2a. Okay, so for the first problem, negative b is going to equal 16. So 16 plus or minus the square root, and you have to be careful. If you type in negative 16 squared, you're going to get the wrong answer in your calculator. It needs to be in parentheses. Or, you know the answer is going to be positive, just do 16 squared. So 16 squared is 256 minus negative 4 times a, which is 1, times c, which is 48, equals 192. No, that's not right. What is it? What's 4 times 48? 192? Oh, great. Over 2 times a, it's just 2 because a is 1. What is 256 minus 192? 64? So 16 plus or minus, this is 64. What's the square root of 64? 8 over 2. And 16 plus 8 is 24, cut in half. So my first root is 12. 16 minus 8 is 8 divided by 2 is 4. Huh. Okay. All right. So the next one. The next one can be divided by 2, and remember, if you divide it by 2, that will change the graph, but it will not change the roots. So if I divide by 2, a is 1, b is negative 10, and c is negative 24. So negative b is 10 plus or minus the square root. Negative 10 times negative 10 is 100. And then negative 4 times 1 times negative 24 is 96. So I like to write the calculation off to the side like this because that will tell me the sign. Is it minus 96 or plus 96? Plus 96. over 2 times a is just 2. Well, 100 plus 96 is 196. What do we know goes into 196? 14? Well, what do you know? It's 14 squared. So that's nice. So 10 plus or minus 14 over 2. 10 plus 14 is 24 over 2. So the first root is 12. 10 minus 14 is negative 4 over 2 is negative 2. Could I have factored that one? Yeah, it would have factored. Okay. Well, you also need to know how to factor. Certain things you need to factor. Not necessarily find the roots, but factoring is important. This one does not factor. Are there two negative numbers that multiply to be 20 and add to be 4? No. So this one, you either have to complete the square or use the quadratic formula. So negative b is 4 plus or minus, what's b squared? 16. So the square root of 16, and then negative 4 times 1 times 20 is negative 80. Well, what do I know about this answer? It's going to be imaginary. The square root's going to be negative over 2. What is 16 minus 80? So this equals the square root of negative 64. What is the square root of negative 64? 8i. So 4 plus or minus 8i over 2. Can I simplify that any further? Does 2 go into 4 and into 8? Yes. Now this only works if it goes into both of them. If this was 5 plus or minus 8i over 2, you cannot simplify it. So the 2 has to go into both terms. So 4 over 2 is 2, 8 over 2 is 4. So the answer is x equals 2 plus or minus 4i. Okay, let's do the next one. Can I divide anything out? I can divide out a 2, and dividing it out makes the problem easier to work. If you don't divide it out, you'll still get the right answer, but you'll have to simplify in the end. So if I divide that by 2, I get 2x squared 5x plus 2. So what is my negative b? So negative 5 plus or minus the square root of 5 squared is 25 minus 4 times 2 times 2. Negative 16 over 2a, and a is 2, so divide everything by 4. What is 25 minus 16? 9. So negative 5 plus or minus 9/4. Then we just look at each fraction individually. Oh, 3, you're right. Sorry. Because it's the square root of 9. So it's 3. Thank you. So what is negative 5 plus 3? Negative 2 over 4. So x equals negative 1/2. Negative 5 minus 3. Negative 8 over 4 is negative 2. Could I have factored this one? Yes. Anytime your answers are rational, it will factor. The only times it doesn't factor is if you have irrational or imaginary roots. Okay. For the next one, can I divide out the 3? I could, but it would make things really messy, so I don't want to do it. So negative b is 6 plus or minus the square root of b squared, which is 36, And then minus 4 times 3 times negative 13. That's the same as negative 12 times negative 13. Well, I know what 12 times 12 is. 144. So what would 12 times 13 be? 156. Just add another 12. And those two negatives cancel. So it's plus 156 over 6. So what is 36 plus 156? So 192. What are factors of 192? Well, I know 2 goes into it. 2 and 96. What goes into 96? How about 8 and 12? 8 is just 2 times 2 times 2. 4 and 3. 2 and 2. Can I pull anything out? 3 sets of 2's. What's left over? 3. So 6 plus, I bring out 3 sets of 2's. What does that give me? Not 6. 8. 2 times 2 times 2. So 6 plus or minus 8 root. What's left on the inside? The only thing that didn't get used was this 3 over 6. Now, here's where you got to be careful. This says the square root of 3, but it's not actually a 3. It's 3 to the 1/2, which is like 1.71. So you can never cancel a square root using a whole number in the denominator. So we ignore that the root is even there. But does 6, 8, and 6 have any common factors? They all share a 2, so I can pull a 2 out of everything, and I get 3 plus or minus 4 root 3 over 3. And that's the answer. Okay? One more, then it's your job to finish. Can I pull anything out of this? No. Okay, so negative b is 3 plus or minus the square root of 3 squared is 9. Then negative 4 times 6 times 16. That's something really big. 384. Yeah? You guys aren't even impressed. Maybe I just remembered that number from last class. Over 2a, which is 2 times 6, which is 12. So 9 minus 384 is negative 375. What goes into 375? 5 and 75. What goes into 75? 5 and 15. What goes into 15? 3 and 5. Can I pull anything out? A 5 and an I, because it's negative. So 3 plus or minus 5i root, what's left over? I have a 3 and a 5 left over, which gives me 15 over 12. And again, when I simplify this fraction, I ignore the root 15. Do 3 and 5 and 12 have any common factors? No, so that is the simplified answer. So there are two ways to find imaginary and irrational roots. You either complete the square or you use the quadratic formula. And really, the quadratic formula is just complete the square in a different form. No, you need to know how to use both. So, your assignment tonight is to use the quadratic formula to do this worksheet. Good luck.